Hello, Claude. Welcome to CW Trending. I'm glad to have you here.
Hello, Jeff. Yeah, thank you. And I'm indeed glad to be there and ready to start.
All right. Well, tell me a little bit about yourself. What is your role at Hexcel? How long have you been there?
I'm Vice President for Sales and Marketing for all industrial business at Hexcel. And I've been with Hexcel for quite a while. It's been about 30 years dealing with industrial business, in different roles.
Okay. And how did you come to the composites industry initially? What's your background?
Yeah, so in fact, it's a very long time ago in my studies. I'm an engineer in thermoplastics and composites. And very quickly, I found out that I had a preference for composite, a little bit more diverse in terms of end application, a little bit more high tech, maybe a smaller market, but I thought it would be more fun. And indeed, I think I made the right choice.
You're based in France. So did you go attend university in France as well?
Yeah, the engineering degree is from a French school. High school over there, yeah.
So it's relatively unusual for somebody, say 30 or 30 years ago to come out of university with some knowledge of composites. How did you first learn about them?
Yeah, in fact, it's pure chance. It's true that I think it was the first course at the time giving an engineering degree for composites. And when I joined the school, I was not sure I would do that, but I knew it was there. And from the beginning, I wanted to go in that direction. At the time, again, thermoplastic was quite hype. I mean, thermoplastic was a type of material where there was a lot of development. I was a little bit less aware about composites during my studies that I realized what it was. I really liked it. And then, of course, I also realized that I like to have more interaction with the outside world, so with customers, with suppliers. And so that's why then I did an MBA to be able to have more of a commercial role rather than just be in production or in engineering. And that's how it started.
That's great. I want to talk a little bit about a new product that Hexcel introduced earlier this year. It's called Hex Ply Xf. Can you tell us more about it? What is it and what's its application?
Yes, so Hex Ply Xf is it's a pre-preg or a semi-preg, which is solving making, let's say, the surface, bringing surface solution to customers. We always try to bring new solution to customer. We always look at what are they doing, where are their issues. Today, there are existing solutions, but what can we do better? How can we help customers? And so we found out that applying gel coat, having a nice surface from the beginning, decreasing the amount of sanding, finishing was really something valuable. So we worked on that and we decided to develop a solution. In fact, it started even more years ago, I think 5, 6, maybe even more years ago. We had a similar problematic in the automotive industry, and we developed a Hexf for automotive, which is quite different from the one we just launched, which is more for very large structures like wind energy or like marine. So this is a pre-preg or semi-preg. It's a very thin material, very light. I would say it's typically 70 grams, but we are flexible. I mean, again, Hexcel is a solution provider, and so we love when we are able to help the customer to, when we can tailor-made a product for a customer, fine-tune it. So typically it's very light and it can be adjusted. I think that's all there is to say. It's using our unique know-how in terms of epoxy chemistry. We have developed specific resin for that. It can as well be adjusted slightly to what the customer needs more specifically, what are their processes, their curing cycles. But fundamentally, it's a resin system suitable for, as I said, very large structures with a minimum, with only vacuum bagging. And it's also suitable for companies using pre-preg as a whole to build that structure, but also for companies infusing. And that's, I think, quite unique.
And so you say it's a semi-preg. You mentioned epoxy. I assume the fiber's carbon is the format.
Absolutely not. The fiber, you have to understand what we're replacing, gel coat. So the fiber is there as a first as a reinforcement, right, to help handle that material and lay it down in the mold. And secondly, is there to give the trick, let's say, and in the end allow a really nice surface when you demold the part.
Okay.
So, but so it's there's a veil glass and other things, and that's it. It's the fabric is more amine than anything else. It is absolutely no use in structure. It's really for us replacing gel coat by another solution. Okay. The other thing that we bring, and maybe I'm jumping ahead there, is that fundamentally we believe and we see that we can replace a certain weight of gel coat by slightly less weight. There's weight saving there in our customers when they move to gel coat to a Hex Ply solution.
Okay, so is it a non-woven?
It's a non-woven, but again, it can change. In fact, we have we say Hex Ply, but it's a wrench, right? So okay. and we're quite sensitive about what's in there, about our magic that makes it work. So there is some very light reinforcement. Okay. With glass and with other things that makes it work.
Okay. So
but no carbon, that's for sure.
Yeah. So you mentioned that this is a replacement for gel coat. So this surface also, I mean, the Hex Ply Xf must be paintable then?
Absolutely, definitely. It is not meant to be finished as is, you know. Yeah, you need to paint after that, absolutely.
So what was the genesis for this product? Were you getting feedback from your customers that they wanted to replace gel coat? Like, what was the opportunity here?
No, I think, in fact, not really, never. As I said, it's more with some customer intimacy. You realize where are the issues. Well, I could say also otherwise. At some point, I think Hex Ply was wondering whether we were trying to expand our product range, and we were wondering whether we should make gel coats as well, because, right, we are approached to provide the full solution. And so at some point we should, should we play in that area? But it's not really our area. So and looking at the limitations of gel coats, I mean, the idea just came, that we thought we had a better way to, we had a different way to approach it. And by partnering with some customer, we realized they had really an interest of, instead of spraying gel coat, having a different format of solution was interesting. And as I said, many years ago, it started, in fact, in automotive, where we found a solution that worked for them, and then they had to paint it. And then we started to think, okay, let's see if we can do something as well for the wind energy, which is then our prime business as well. Again, investigating, seeing the limits, we could see that very often the finishing, so the gel coat and finishing of the blades is a bottleneck in operation. Right. And they spend a lot of time. It's very dirty. So we thought, okay, do we have a solution that would help there? And that's why we developed that product.
Okay, so you mentioned the wind energy industry and blade manufacturing. So just walk me through how Hex Ply Xf is applied, in wind turbine blade manufacturing, and what kind of operations maybe are not needed yet, because you mentioned that currently sanding is pretty messy, so maybe that's something that the fabricators don't have to do. So just walk me through that.
So yeah, the beauty of a Hex Ply is very easy to use. So it comes in a roll. The width can be selected or determined with the customer, so it's the most suitable for them. And it's just like any pre-preg, you lay down on the tool directly. You put the sticky surface on the tool, and it holds there, and then you go and apply your standard layup for the structure of the blade. No other change for the customer. So that's really nice and really easy to integrate into a current process. So it also doesn't require debulking. It doesn't, it's really easy, and we really always like to make things easy for customers. That's how you get a greater adoption, I think. Then so does it remove completely the need from sanding? Well, so far, I would say, unfortunately, not. I could say, again, it depends on so many things. What construction you have behind, reinforcement you have behind, how the customer is, it's his own process. I would say fundamentally, no, unfortunately, we can't say we have little hope to completely replace the sanding. But usually it's sanding plus then you have to how can you say, some finishing. So you need to put more some material, repair and sand again and so on. And that's where we think we add value, because you can sand less and with less repair. That's the overall idea. And that's with more experience that we will see that will also help us to continue to improve the product so that it's kind of bulletproof to anything that can happen during the process of the customer, so that it's really minimum work for them.
Okay. You mentioned it's a semi-preg. It must have some out time limits, but the wind energy industry, it's large molds, a lot of material, a lot of out time. So how does that work?
Yes, so I like that question, because it gives me the opportunity to break the idea that pre-preg or semi-preg are let's say fragile, need fridges, and it's not true anymore. We have, it depends, of course, but we have some system with extremely long outlife like this one. You can put your material in rolls for 6 weeks at room temperature, as long as you have a room temperature control and you don't reach 50 degrees C, as long as you don't go, I think it's over 30 degrees, you're fine, can go for 6 weeks. Okay. So it's really, nothing special. And again, we're back to the fact as well that in a lot of cases, the composite has now become a real industrial industry, in the sense of we talk just-in-time deliveries, and Hexcel can do that. We talk, the customer is not supposed to store material for ages in their shop floor. We're there as well to bring a service where the rolling of or let's say the time the customer will have the product in hand will be a week, 2 weeks. I guess it's a bit longer for wind energy because they have so many material, it takes so long to build the blade. But for smaller components, they can have it for a day or 2 days, and then we replace.
So you talked a little bit about sanding. So sanding, I guess, is less or minimized with Hex Ply Xf. What other benefits are you seeing that this material conveys to a wind blade?
So one of the benefits we see is that it's lighter as well. As I started to mention it earlier, I think we have the impression that we should be able, we've demonstrated a few times that we're bringing 50% weight saving on it. So, you don't need, and by weight saving, you also mean material saving, by the way. Yeah. So, and waste saving. So I think that's a great advantage. Then it's much easier. It's not easier. It's by definition, you have an even application of your surface solution, which is not the case of gel coat. Or on the contrary, if you want to be sure to have more gel coat or more in certain areas, you can as well do it. You have perfect control of your distribution of your surface solution, which you don't have the same way in gel coat. Finally, as well, of course, for a newcomer or for a company growing, it's equipment. So it's the spraying, it's all the mixing equipment that you don't need to invest in. You don't need anything special, anything different than what you already use for your dry reinforcement or your pre-preg. So again, it's an investment saving, and fundamentally overall, it's saving time. So it takes less time to deposit that material, and then, as I said as well, the sanding time as well. So overall, same thing. If you're in a ramping phase, you can offer a little bit more throughput to your customer than the standard gel coat.
This must have application in other end markets that use gel coats, like marine. Are you seeing application there as well?
Yes. So marine, definitely, because it's so similar. Of course, the parts are a bit smaller, but not much. And we've had already a few successful application in with luxury yachts in sun canopy. So absolutely, definitely. And again, it's a very similar product. Very similar product to the one that we supply in the wind energy, because of course the type of resin system with long open time and the time of performance is required, expected is the same, and yeah, it's very encouraging. And same, it can work with epoxy infusion as well as with break, whatever the customer utilize already.
Okay. And what is the thickness of this, of Hex Ply Xf? Does it range? Do you have a thickness range, or what is the standard thickness?
No, I said typically, I'm not sure there, I would have to check, but I would say typically it's a 70 GSM material. So, yeah. Pretty
light, pretty thin. Okay.
Yes. Another thing, again, we say except because it's a surface solution. One thing, I mean, it is not provided today. We just need to have the demand that fits with the customer. But you can also, that product, you could already apply it to the first ply of the customer, again, saving time to the customer, right? So instead of having 2 layers to put in the mold, they would have one. So all this is already in evaluation, and many other things are in evaluation in Hexcel. In fact, we're working really on surface solutions, really, and how can we continue to enhance that product form, which is very promising.
Finally, one of the challenges of a wind blade in operation is coping with leading edge erosion and degradation over time from ice and wind and rain and sand and everything. Does this material help in that performance at all, or is that maybe another application you're looking to help with?
I would love it, but I would say no. I have to say, unfortunately, it's absolutely so. But you raise a point where, of course, we're looking into that. So, but the product as it is today, no, you need special chemistry. You need much more than just what it gives today. Just like gel coat, the same gel coat as in the blade doesn't fit, doesn't solve much into the tip and the erosion at the tip. It's the same for that product. But yeah, it's certainly an area where we're looking at. It's helping to find a solution for these tips, in the leading edge, where you have more and more erosion and more challenges with these bigger blades.
All right, so stay tuned there, I guess, huh?
Exactly.
I'd like to talk more broadly about the wind energy industry. The wind blade manufacturing, wind turbine manufacturing, I think is one of the bright spots of the global economy through the pandemic in general. So just wondering what your view is of wind energy, its application, its growth, and what do you see happening here in the next few years?
Yeah. So yeah, for sure. I think wind energy was not too much impacted by the pandemic. I would say, well, they were a bit because of the restriction in travels, and so they couldn't access sites to be able to build and implement the blades. I also want to say that the industrial business in general did very well during the pandemic, and of course they went down, but it went back up quickly, much faster than the aerospace. So it's there's a lot of bright future in the industrial business. The wind energy, that's clear. I mean, with all this trend for renewable energy, it has bright future. I mean, I'm quite sure. I remain, of course, cautious, maybe because I'm French, and so I hear so much negative things in France. But that's a personal note. No, I think we'll go on. It's offshore will boom, and what we really like, again, as in Hexcel, where we're really a provider, as I said, of high-end solution technologies. is this longer blades, turbines that can, that are, it seems that there's no end to the number of megawatt by turbine. It all creates this demands new solutions, right? Because these gigantic blades, drive for new solutions. And so I can't share more or say more. I mean, it's more a turbine manufacturer that you need to question, but I'm sure there will continue to be an evolution of the demand of the technology, steel composite, but it is not it's not a market which will stay with the same solution forever. And there's new challenges like split blades, like the fact that they have to integrate more carbon because the blades are longer.
Yeah. So let's talk a little bit about that, because right now, standard blade manufacturing is primarily glass, foam, balsa, and then typically if carbon is used right now, it's in the spar caps, and most of those spar caps are now pultruded carbon fiber. Consumes a lot of material, but as you noted, blades are getting much longer. And do you foresee any substantial change in material architecture? Is it possible we'll see carbon used in place of glass in certain places? What do you think is a fair expectation looking at how this is evolving?
I think the wind business and the blades will continue to use as less carbon as they can, in the sense of as soon as they can avoid it, they'll avoid it. Having said that, I was just mentioning these issues with the size of the blades, so which is really I think it's probably, and again, I'm not the most expert, but probably also a dilemma between your structure, your weight, so other costs that you have in your whole turbine cost if you choose to make a heavier blade, or if you put carbon in it, right? So we know that some of the players had made the bet to go carbon quickly, and some just dragged on their feet, but they are also coming to carbon, I think, simply because of the magnitude of the blade. So yes, carbon in the spar cap will develop more and more. It is today protrusion the most preferred option. I think it's a very good option. I think, in fact, fundamentally, why is it a good option? It's a cost, but fundamentally what the blade manufacturer want is something pre-cured. They don't want to have to bother, let's say, curing carbon, injecting, whatever. Consolidating carbon with resin is much more challenging than glass. So it makes their life easier to buy something which is resolved, cured, let's say. Right. So today it's pultrusion the solution. Will it stay? Probably. I can't bet for them. I'm sure they're looking at other things. Eventually, we'll see. But it's a smart solution. Yeah. Now the big question is the carbon fiber in itself. Carbon fiber. So it's a massive consumer. This application is a massive consumer of carbon. I see, but again, I'm not sure where it's going to go. There is, I think, different option between today, it's like kind of very low end carbon, lower performance carbon, the cheapest you can get, commodity fiber. Maybe I put a little bit more of the laminate, but it's commodity fiber, or I kind of fine tune and go to a higher end carbon fiber. Okay. A little bit, you add a little bit of GPA. Yeah. So a little bit of price, but then you can design differently and maybe design differently and offer us other solutions. I am convinced that both options are being looked at. I'm not sure which one will win. I hope the one which will show that a little bit higher end product will be a better solution in the end. I hope it will win, but I cannot guarantee. Is that the designers will tell. But for sure, it's also the resin. It's the fiber ratio. How far can you go and so on. There is, I would say, some turbine OEM go for commodity, kilometers, same basic product you can buy from anywhere, and some are going more for fine tune, performance. You can still have a basic commodity plus a little bit of fine tune. Let's see what happens. We're looking at it.
Okay, so a lot of opportunity there, and so it sounds like OEMs are doing a lot of cost-benefit analysis and trying to decide where that line is for each of them and how they want to apply this fiber.
Yes, and if I may, and I think you said, if I may add something, I'm very curious about to see what's going to happen in the next years because of the boom in the hydrogen market. The low price fiber used by and the massive capacity used by the wind energy market is going to be competing now with other emerging market looking for a higher end fiber, still cheap, but much higher end. And there is not enough capacity for everybody. So what will happen with the lower end? Will they run out of fiber and then will new players appear?
Right.
Which will be focused on that only? Will they go for an alternative fiber? Even, there's I don't know, but I'm very curious to see what's going to happen in the next years.
All right, so you mentioned hydrogen, so let's just talk a little bit more about that. The hydrogen economy is growing extremely quickly right now. And this is across the board. This is in aerospace, ground transportation, rail applications, buses, trucks, passenger vehicles. So we're talking about storage of hydrogen primarily for fuel cell vehicles. And we've been reporting on that quite a bit, and there's just a lot of activity there. The challenge here is storing the hydrogen, and that's typically done with a pressure vessel, and if you're going to use composites, then it's going to be carbon fiber, as you mentioned. What kinds of carbon fiber, what types of carbon fiber are you seeing demanded for these applications? And you mentioned there's a potential shortage. There could be a potential supply problem. So just talk to me a little bit about what kind of demand you're seeing and what the supply situation might look like.
Yeah. So the hydrogen economy. I mean, what the hydrogen economy is creating here for the composite market is very exciting. I mean, I'm really thrilled about what's going on because again, it's high end. There's hydrogen. The hydrogen hydrogen storage market is the most obvious one, the one impacting the most the composite world, but that's not all. And indeed, it's high-end fiber. I mean, it's typically, I'm sorry, again, I'll use European metrics, but it's a 5,000 to 6,000 MPa fiber type. Again, where will it go? I think there's going to be, for sure here, this dilemma between performance and quantity of fiber by tank. And today, Today, the main issue is the capacity constraint. There is no way. There is fantastic projections of demand for 2030 and beyond. There is no way. I don't see any reasonable way to reach capacity able to meet that demand. So right now, but I hope people will find solution. I hope there will be a solution, but right now it's such a challenge because of the time it takes to invest, the time it takes to get the equipment to build the lines and so on. So I think being reasonable and reducing the amount of fiber within the tank but maybe thanks to a better performing fiber or a fiber with better performance translation on the tank will be very useful. So indeed, so I said it's a 5,000 to 6,000 MPa. They're more 5,000, maybe so pushing more to 6,000 in the future. I don't know for sure, but my guests are telling me we'll probably go a little bit higher, or if not higher, it's a better translation on the composite, which is today not so great. So it's definitely a market we're looking at. We are much more in a courtyard comfortable to Hexcel. Right, it's our today. It's where we like to play because it's much more similar to what is used and what needed the aerospace industry. It's similar, not the same, of course. We're not, for instance, in the same tool count. You need bigger fibers. But again, I was also mentioning translation, which means you need to think of the surface treatment, the sizing of your fiber, all this, and again, Hexcel likes to play on chemistry and likes to find the right solution. So it's something we're exciting to look at. As I said, I think until now that market was fundamentally owned by only a few players, few fiber players, which were so good at it. But I think now the market will need kind of all the big players to come in to have a chance to meet the demand that they want. That's my view.
Yeah, I don't think anybody can stand on the sidelines when you look at the amount of fiber that's going to be demanded for this application. You mentioned toe count. Are you typically seeing like 24K, 50K? What do you expect?
Yeah, it's typically 24K. I think we should not talk necessarily in K. We should talk in linear weight because that's what's important. But it's typically a high strength fiber, 24K. Yeah, and yeah, the heavier you get, so there's probably a limit. You know, would the 48K be useful? I'm not sure. I'm not able to answer that question yet.
Okay. And there's a cost sensitivity here too.
Yes.
Obviously, a carbon fiber pressure vessel is going to be much more expensive. It's also going to be much lighter. And when you're talking about fuel cell electric vehicles, weight really matters. So what are the dynamics there?
So yeah, there is a cost matters. So we'll see where this will end up for it, but it is not at the level again of where the wind energy went. I think because you need performance, but I think there'll be a solution. I mean, again, there is today in the cost of a tank much more than again the cost of the material. So it's true that the cost of a fiber is a big part of the but I'm back to the same logic as that when we developed XF, right? What you want is to provide a solution to the customer that will need to invest less to be able to manage his ramp up.
Yeah.
Right? Because they're in a ramp up phase, they're in an exploding phase. And what do you want? You want the first fundamental is you want a plant with 100 lines, or you want a plant with 50 lines or with 20 lines. And here there is a lot to play. That's why there's a lot of discussion today between wet technology and toe preg technology. Okay. So until now it was mostly wet, but I think I'm sure you know, and you hear toe preg is being investigated by everybody. And of course, as a fundamental composite player, I believe that toe preg is going to bring a lot of benefit, and it's going to be the solution because of that massive volume coming in, and because it can offer so much more.
Okay, so to be clear, you're talking about the possibility of increasing the efficiency of manufacturing by using toe preg to wind these pressure vessels, and potentially offering the opportunity for somebody who's making these pressure vessels to have fewer lines that are more efficient, even if the material itself is maybe slightly higher end or higher performing. The attributes of the material allow you to be more efficient and productive in manufacturing these tanks.
Yeah, absolutely. And we'll always be very cautious at checking that we have the same. In the end, what matters is the cost of the tank, as I said. And so the way we like to work is hand in hand with the customer to have that target of the cost. What's the end cost, and how can we help to be still at the same or below in terms of the final cost for the tank. And I strongly believe that toe preg can do that compared to wet. It's not because everybody will say it's a bit like, resin plus fiber is always cheaper, that's clear, than toe preg.
Right.
But there's much more than that.
Yeah. So you mentioned that if I recall, it takes about 2 years to manufacture and bring a carbon fiber line into service. So for anybody watching, do you have any thoughts about what kind of milestones or what kind of information points we might look for, say, over the next 5 years that might tell us where this market's heading? Or, are you watching application of fuel cells in passenger vehicles the most, or are you paying more attention right now to, say, trucks and buses, or what kind of data points should we keep an eye out for?
Yes, of course, we're focusing. We prefer to focus on what we think is the most promising. I can't say much more. You're totally right. You're spot on, and yeah, that's, we'll see. So it's very difficult for me to give a milestone. I think almost every year is going to be a milestone. I mean, there is already programs. When you look at the orders coming in for electric vehicles, but so hydrogen vehicles.
Yeah.
The system manufacturers have to have solutions now, and it's like, how often will they change their solution? In the sense, they have to go with whatever is available right now for the first orders, and then incrementally they will take that decision. What's going to be the decision rhythm? I'm not sure. Maybe every year the changes. I'm not sure. We're right. It's a surprise. I mean, this market exploded during the COVID. So even though we knew it was a big market, even though I must say 10 years ago, I thought, wow, that's a fantastic market. I bet one day it's going to come. I was not expecting that wave to come now, thanks to the COVID. So probably in a year, if we speak, we'll know better. We'll have a better vision, but it's really very thrilling market.
Well, yeah, I think you're right. It's been a pleasant surprise, and we'll just have to keep in touch and see what happens.
Exactly.
All right, Claude. Well, I appreciate you joining me here. This is really good information. And really enjoyed your comments. So thanks again for joining me here on CW Trending.
You're welcome, Jeff. That was a pleasure for me.
Have a good day.
Thank you.
Bye-bye.
Bye.